To use the lab, expect it to fully charge into the computer's memory. The charging time may vary depending on your internet connection. Once it has loaded, you have two options, experiments and controls. By touching the controls button, you have access to a screen where the ways to control the simulator are described. To move in the environment, use the WAS and D buttons, respectively, for the forward, left, back, and right directions. These directions depend on your orientation in the laboratory. The direction you are looking at will be the forward direction. To zoom in or out, use the Z key. To lower and lift, use the CRTL key. The right mouse button allows you to make changes in the direction you look at, while the left button allows you to select objects. This selection can also be made with the letter E. The Enter key takes you from any part of the lab to a control menu that allows you to go to other phases, restart the stage where you are, or continue the activity in the stage where you are. The button with the expansion symbol allows you to view the lab in full screen. To return to normal viewing, press the Escape key. By clicking on the Experiments button, you are taken to the Experiments menu, which has the experiments available to you to perform in the laboratory. No defect, defect 1, defect 2, defect 3, defect 4 and defect 5. Let's exemplify access to them by choosing the defect 5 experience. When the simulation is started, you are positioned in the laboratory near the emergency exit. Note that in the lower region of the screen, there are instructions that guide you through the process. Right-click and move the mouse. You can then change the direction you are looking at by simulating the turning of your neck. By using the scroll keys, you reproduce the act of moving through the laboratory. To start activities, you must use personal protective equipment. To do this, go to the PPE locker, located on your left. Click with the mouse on it to open it. You will then receive the PPE. Touch each of them to dress them, according to the instructions, either lab coat, ear protector, gloves, glasses and helmet. Walk through the lab. Walk through the lab now. By doing this you can check out various interesting details such as safety signs and the position of collective protective equipment, such as a fire extinguisher, a gas exhaust hood, a shower head and an eye Washington. The machine where the measurements will be taken is a motor pump. Note that the pump is centrifugal type and is driven by an electric motor. The pump shaft is supported by two rolling bearings. The same applies to the motor shaft. A flexible coupling joins the two shafts and allows the rotational movement of the motor to be transmitted to the pump. To start the measurements, go to the counter near the PPE closet. You'll find a suitcase over it. By clicking on the briefcase, it will open. Inside it are the sensor, which is of the piezoelectric accelerometer type, and the vibration analyzer. You will learn about these equipments in lesson about vibration measuring chain. To get them, just position the mouse over them by clicking the left mouse button. You can then go to the equipment and make the measurements. Let's look at the picture on the wall with the references of the measuring points. Note that you will do the measurements in 4 sections. They are located on each of the bearings, both the pump and the engine. The directions measured at each point will be horizontal, vertical, and axial, except for the points in sections 2 and 4, where the axial component will not be measured, for reasons that will become clear during the vibration measurement chain class. When looking at the machine after you have taken the sensor and the analyzer, you will see that arrows have appeared to help you locate the measurement points. Click on one of the arrows and you will position the sensor at that point. To turn on the analyzer, click the power button. you will immediately see a signal on the analyzer screen, which is showing a vibration in acceleration in the time domain. When you touch the VM/time/FFT button, you will switch between the same signal graph in the frequency domain and the RMS signal value. To switch between average values and instantaneous values, touch the INST/RV button. The instantaneous time domain signal has a purposeful delay to allow you to see more clearly the waveform, since you have accurate information about frequency in the frequency spectrum. The sensor picks up the signal in acceleration, but through a numerical integration process, it is possible to obtain speed and displacement with the instrument. By clicking the ACC/full/disp button, you switch between these quantities. Zoom operations are performed independently on the horizontal and vertical axes of the machine. For horizontal zoom, press the zoom/expand/move key and then the right or left arrows to zoom in. For vertical zoom, press the scale/on/off key and then the up and down arrows to control the zoom level. Zoom can be done in both time domain and frequency domain. An interesting feature is one that allows some characteristic frequencies of defects and their multiples to be shown through red lines. You will learn about these frequencies in the spectral analysis video lesson. This feature is reached by the line key. To switch between the frequencies shown, use the up and down arrows just below the line key. Normally, you register the characteristic frequencies of your equipment when you configure the analyzer for your measurements. In this case, the analyzer is already configured with the motor pump data. The codes of each frequency are described in the supporting material. The light button allows you to control the illumination of the analyzer monitor. Take advantage to observe the details of the measured signals using all the features that the analyzer puts at your disposal. Have good experiences in the lab.